Alright, today's lesson is about how to solve quadratics by completing the square. We're just going to do the first part of this lesson today, and then the next day we'll do the other part. Just to kind of warm us up, we're going to look at this equation, or not really equation, expression, trinomial expression. We're just going to factor it. It's a trinomial, so of course we typically factor trinomials using the diamond. So I'd put a 36 on top, negative 12 on bottom. Then I'm looking for numbers that multiply to equal 36 and add to equal negative 12. So that's negative 6 and negative 6. So I can factor that as x minus 6 and x minus 6, which simplifies down to x minus 6 squared. Now, what's cool about this trinomial is that we call this a perfect square trinomial, because the first term is a perfect square, a positive perfect square, and the final term is a positive perfect square. So when that is the case, we can actually just take the square root of the first term, then the square root of the third term, and put those in a parentheses together, and the sign that would separate them is the sign that immediately follows the first term. So in this case, it's a minus sign. So we can always just do that. That's a nice little trick to have in our tool belt. They're rare. They're not super common, but they do pop up from time to time in algebra, and so it's good to have that skill to simplify those. Next thing we're going to look at is the square root property. The square root property tells us that for any number that is greater than or equal to 0, if x squared equals n, then x is equal to the plus and minus square root of n. So what that means essentially is that the square root property tells me if I need to take the square root of an equation, I can, as long as I do it to both sides. So x squared equals 121. I can take the square root of both sides, but because I'm the one deciding to take the square root, I have to take the positive and the negative square root of 121. So that means that x is going to be equal to positive and negative 11. And so a simple way to solve those. Now I do want you to remember, keep this in mind, not all quadratics have solutions that are whole numbers. It would be nice if they did, or even if they were all just fractions. That would be nice too. But unfortunately, there are roots that are irrational numbers. And if you do get one of those, then of course I want you to write those as exact answers in radical form, unless you are specifically told to write your answers in a decimal form, in which case then you can round, type that number into the calculator and round whatever it spits out. Most of the time, though, I want you to leave it as an exact answer in radical form. Now, sometimes solutions of quadratic equations are not real numbers. Sometimes they are complex numbers, and they can be written in the form a plus bi. So we want to solve the quadratic equation here using the square root property. Now, the first thing we got to do is we got to factor that, because we have a perfect square trinomial, x squared minus 4x plus 4. So we can factor that down to the square root of the first term, which is x, square root of the last term, which is 2, and then we're going to separate it with that sign that's immediately following the first term, so it's a minus, equals 25. Now I can take the square root of both sides, and again I do have to take the positive and the negative square root, so I get x minus 2 equals plus or minus 5. So from here I have actually two equations going on. I have x minus 2 equals positive 5, and x minus 2 equals negative 5. So to solve this, just set those up in two separate equations, add 2 to both sides, I get x equals 7, add 2 to both sides here, I get x equals negative 3. So my final solutions are x equals negative 3 and 7. Whenever we get solutions like that, I really want to encourage you to start checking your work, checking your solution to make sure that when you put it back in the original equation, it works out. That is how you know for sure that you have the right answer. You never have to be uncertain. So if we put negative 3 squared minus 4 times negative 3 plus 4, does that equal 25? All right, well, 3 squared is 9. Negative 4 times negative 3 is positive 12. So we get 9 plus 12, that's 21, plus 4, that's 25. All right, so that checks out. Then I have 7. Run that through the function. 7 squared minus 4 times 7 plus 4 equals 25. So that's 49 minus 28 plus 4 equals 25. Well, 49 minus 28 is 21. 21 plus 4 is 25. So that checks out. So both of those work. So we have 2 good solutions. Now, moving on here to the back page. We're going to solve this quadratic equation using that same principle. I got x squared plus 24x plus 144. Okay, well, the first term is a perfect square, x. Second term is a perfect square, so the square root of that is 12. And then we're going to separate it with that sign, so plus 12 equals 192. I'm going to put a little more space there because I know I got to write some more stuff there. So now I'm going to take the square root of both sides and the plus and minus square root of that 192. And so that means I've got x plus 12 equals, well, the square root of 192 is not really pretty. It's going to come out to a decimal if I type that into my calculator. But we can simplify it. The square root of 192 is divisible by 64, which means that the square root of 64 is 8. And what's left behind is the square root of 3. And so I have x plus 12 is equal to positive 8 square root 3. And I have x plus 12 is equal to negative 8 square root 3. So I have x equals negative 12 plus 8 square root 3. And x equals negative 12 minus 8 square root 3. So my answer is, I can just write that as x equals negative 12 plus or minus 8 square root of 3. And that is my final answer. Okay. So solve the quadratic equation using the square root property. Well, unfortunately, I do not have a perfect square trinomial here. 2 is not a perfect square, neither is 1058. However, I can divide both sides by 2 to get x squared minus 46x plus 529 equals negative 36. And I do know that x squared and 529 are perfect squares. The square root of 529 is 23. Separate those with that subtraction sign. Alright, so now I'm going to take the square root of both sides. And again, plus and minus. So we get x minus 23 equals plus or minus, and the square root of negative 36 is 6i. So, final answer here. We saw in the last one when I separated them out, I still had to put them back together. I'm just going to leave these together. 23 plus or minus 6i. And that's my final answer. So, short and sweet lesson today. Hope you are able to follow along. If you have any questions, please let me know. Send me a Canvas message or an email. Talk to you later.